That's the best I can zoom in, right? So we have three quantities to look at. Four quantities that we're going to look at: displacement, velocity, acceleration. And which one is it? It's in kinematics. Displacement, velocity, acceleration, and one more. Displacement, velocity, acceleration, and time. Okay. So we're going to take a look at those quantities, right? Quickly, distance traveled by an object from a point is the total length, right? So something we should remember from Form 1 is that if I give you an object like this, right? And the object went here, went here, went here, and went here, the total length traveled is distance, right? But on the other hand, straight line distance from start to finish is your displacement. Okay, you don't have to write this is in your notes, right? Right, displacement, straight line distance. Right, before we move on, let's say I started here. That's our reference point, right? And I have an object, and the object started here and it moved up here. That distance is 2 meters, right? What is the displacement from O to E? It starts at O and it finishes at E. Displacement is 2 meters, right? But suppose you start at O and you finish at O. The displacement is what? 0 meters. That's okay? You start and finish at the same point, so your total distance is 0. Straight line distance is 0. Online, are they okay? Darren, pay attention. All right, so carry on. All right, so what's it here? Let's say now you started at O, right? What's the thought, right? You start at O, you went to E, you reach back at O, and you went to equivalent distance below B. What's the displacement O to B? Minus, right? That you went below your starting point. So you're in the opposite direction. So your direction change. So your displacement is minus 2 meters. Are you okay with that? Yeah? So it's important we understand that sign convention, right? Just like velocity, you're moving in one direction, positive, you change direction, it becomes negative. Okay? Pay attention to that with displacement as well. Nice, we know the SI unit of vector. Speed, distance moved per unit time, same symbol. You also know is rate of change of distance travel. Average speed, total distance travel, total time, scale of 1. Right, nothing new there. Velocity, the change of displacement per unit time. Velocity is a vector quantity, right? And average velocity is initial plus final divided by 2, right? U plus V, U is initial, V is final. They have both velocities, right? Last one, acceleration. Acceleration is change in velocity per unit time. And we know that it's a vector quantity. We know that also, if the velocity is changing, there's an acceleration. If the velocity is slowing down, there's our, what do you call it? Deceleration, right? But if the velocity constant, then what do we have for it? Oh yeah. Yeah, if velocity constant, then the acceleration is 0. Right? There's some basic things to remember. Right? And hopefully you remember the formula, right? We're not doing time graphs today, we are doing kinematics, equations of motion. Right. So let's go to the board up on there. So I want you to head up equations of motion. Right? There are 4 equations of motion. We have to be able to prove them and be able to use them. Right? We have to be able to use them properly. Let's go to the board there, 1 line. Daria, you listening?
Yes, sir.
Mic too, boy. What? It's serious today, boy, Daria. All right, so let's go. So I wanted to head up equations and motions, right? There are some equations that we're trying to prove, and the order to do it is the best way for you to remember how to do the proof, right? So before we start equations and motion or come up with the new ones, we have to go with the equation that we know already, right? So we know that acceleration is change in velocity divided by time, right? If I rearrange this and I make v the subject of the formula, I'll get a by t. When I carry across the minus u, I'll get plus u, right? So that's our first equation of motion, right? We have three more to do. Since we know this, we just learned that average velocity could be total displacement divided by total time. That's okay? Yeah. And we also learned average velocity is what? Right. Initial plus final divided by 2. So if I move t across here, I'll get half u plus v by t. That's okay? Bring up the half, try by t. That's our second equation. That's okay? Are we done? All we gotta do now, put v in here and put t in here. And we get equation 3 and equation 4. Right? So if I substitute equation 1 in equation 2, I'll get S is equal to 1/2 u plus, upon what v is u plus at multiplied by t. Right? If I multiply this out, I'll get half. If I add this up, I'll get 2u plus at by t. If I multiply this out, a half by 2 will give me u by t will give me ut. A half by at will give me a half at, t by at t squared. Right? So I multiply by everything by a half t, and I get this, a half t by this, and I get this. Okay, we're watching it happen. Yeah? Equation 3. Are you okay with that? And then, yeah? And then since t, I can make t the subject of the formula there. T is equal to what? V minus u all over a. So I could take it now and I put it in here. And I could substitute in equation 2. So I'll get S is equal to half u plus v by t. T is v minus u over e. Right? More people multiply that out. Let's see what she gets. And that will be a last equation. Right? Remember, you can run from maths, right? Physics. About. Huh? Have what? Previous motion. There's 4. And 1 from it. Okay, what is it? The group, in the group. Yes, we remind me of something. Like this. And then and then L. So I'll put it again and I'll so we'll put it give me now open the side. Oh yeah, multiply it out. And then we're going to take a look at using this, right? I sent you a smaller document there. I'm still working on the editing right now, but I give you some questions there that we're going to practice today. All right, let's go and look now. Right, simplify all the way down, right? Simplify all the way down, make it look nice. So I will get S is equal to, I'm bringing the 2 underneath here. So it will be 2 by A. And if you look at this closely, this is the factorization for difference of two squares, right? So you get S is equal to, when you expand this out, again, V squared minus U squared over 2A. Cross multiply, and you will get V squared minus U squared is 2AS, and I can make V squared the subject. You'll get U squared plus 2AS. Right? That is your equation 4. Oh, lowercase s. Yes. So those are your four equations of motion, right? So these obviously they are equations and we use them to solve different things, right? So what you look for, you look any question you get. You look and you see what quantities they gave you, right? So you're checking to see your quantities. You have VUATS, right? I will number them 1, 2, 3, 4, 5. So tell me which equation you think I should use here, right? Suppose I gave you VUA and I want you to find T. Which equation you'll use? Suppose I gave you VUA and I want you to find T. First equation, right? Suppose I gave you V, U, and S and I want you to find A. If I gave you V, U, and S and I want you to find A, you're using that equation. You can't use that equation with time in it because I didn't give it that. That's okay? Same principle. Suppose I gave you U, T, and A, and I want you to find S. I gave you U, T, and A, I want you to find S. Equation 3, right? So you're basically taking the information given, write down what they give you, and then figure out the equation to use, right? There's one more important thing I want you to understand, right? When you're using these equations of motion, every single one of the quantities that are vector must be in the same direction. So this is a vector quantity, vector, vector, vector. Time don't really matter, right? Because time is a scalar quantity. So for example, if I go in this way, it means that my velocity must be going that way. My initial velocity that way, acceleration this way, and my displacement must be measured along same direction. That's okay? So if you want to use the equations of motion, all four must be in the same direction. If, for example, you have displacement vertically, not horizontal, you can't use it. Okay? Everything must be in the same direction. So for example, as I said, if you have displacement vertical, then your velocity must be vertical, your initial velocity must be vertical, the acceleration must be vertical. Right? That's okay? Every single quantity must be in the same direction, all the vector quantities. All right? So I gave you a series of questions. If you look at the handle, and we're going to do, if you can do all today, good. Yep. Right, but I'll tell you something after we finish it all. I have two topics tied into one here. Right? We're not doing all, I'll give you the answers for all, but right? So let's start with number 1 and easy. Number 1 and easy. Right, so go to the handout. Everybody have the handout? Let's check in the group, right? Check in the group and we start with number 1 easy. Write down all the quantities they give you and let's select the equation, right? Everybody have the handout online, right? Yeah. Just online, yeah. Everybody have it online? You have it? Right, take a little read. Finish. So what do you think now? Which equation we using for number 1? A car starts from rest and accelerates at 2 meters per second in 5 seconds. What's the final velocity? The answer. I wonder what the equation. Sorry? First equation, very good. So you're using the first equation. Work it out fast. If you finish, number 2 one time. And then we all in the easy, yeah? think I put some extra hard, so I want to work on the hard one. Online, want to finish message your answer, right? So we're using equation 1. Right, so as soon as they read, the first thing they do is right what they give you, right? They give you acceleration. Please pay attention and make sure they're in the right direction, right? Time 6 seconds. Initial velocity is 0. They want final velocity. Right? So we're using V is equal to U plus AT. Sorry? 5 seconds, so which one? Push-ups on level 2. Sorry about that. Sorry, I skipped the level 2 by mistake. One and two. Right, so we'll end up with V is equal to 0 plus 2 by 5, 10 meters per second. Try number 2. Right, use their value for acceleration, right? By the way, acceleration moving upwards, positive or negative? Negative, right? Right, so when the acceleration going upwards, right, the G, object moving upwards, the G value is negative. Okay. 1, 2, 3, and then we would change. Like that. So a ball is thrown vertically upwards with an initial velocity of 15 meters per second. Right, we're doing 1, 2, 3 and easy, right? Just to make sure we understand what to do. Yeah, understand what to do? Okay. How long will it take? How long will it take to reach maximum height? Right, there's one rule I didn't give you. What's up, not max height? It's 0. Right? I forgot to give you that, right? At maximum height, V is 0. So I know what the final velocity is. So I can find for T. No, sorry. And what you right thing? Right. A ball is thrown vertically upward with an initial velocity of 15. How long will it take to reach a maximum height? Right. Final velocity is 0, so they want S. So which equations we using there? 1, 2, 3, or 4? 1. Sure. That's what S is at the time. I'm watching the wrong thing. Hold on. Sorry. I'm watching the wrong one. Number 2 is the end. Sorry. Time to reach maximum height. So we're using right? We're using V is equal to V minus U over E. Right, thank you. So V is 0 minus 15 over minus 9.8. How much you got? 1.53. Second. Let's go again. Number 3 easy. Any questions online? Are you okay? Chris? You okay? Right, after number 3 easy, number 4 hard. Sorry, number 4 medium. Right? All of them easy. Right, let me start watching the right one this time. Huh? The car moving at 20, right? A car moving at 20 meters per second decelerates at 5. So acceleration is minus 5 meters per second. How long will it take time to come to a stop? Same one, yeah. So that'll be V minus U over A. What's important here is that you recognize A is minus 5. Huh? 0 minus 20. So you got 4 seconds. All right, next one. Right, try medium, number 4. Questions online? Are you okay? Katrina, which one is that, Katrina? How far you reach? Now you're not paying attention. We finished 1, 2, 3 easy. We are number 4 hard now. Number 4 medium. Oh, okay. So we are number 4 medium now. All right, did you have here, Darian? Because I'm not paying attention at all. Yeah. Pardon me? You can take out. You can say that. Five. I think I would have to see an idea. Well, I think I have to see a medium. So I don't have number 5. 5 medium. Right, let's check out medium 4. Medium and non-medium 4. Huh? It can't decelerate. So they give you the deceleration is -4. And they give you from a speed. So that's the initial speed. How far does it travel? So what is S before U is 0? So we have V, U, A, S all in the same direction. So we're using this, right? So we're using V squared is equal to U squared plus 2AS, right? So that would be V squared minus U squared over 2A, right? V is 0, U is 30 squared, and A is -4. So when you work it out, how much you got? Was it displacement here? How much? 112. 112.5, right? Okay, that's number 4, then number 5. Any questions online? After number 5, we try to do as much studying hard as possible. So I plug it into equation 4 and get the same thing here. Into equation 4, but we do at time. That was number 4, Dylan. Huh? Oh, yeah. Well, if you calculate time first, yes. So if you calculate time first, then you can do that. So you divide, so you can substitute the time where V minus U and then divide by T. Okay. All right, Daria. Right, so if you find time first here, use equation 1 and find time, and then use equation 4. That can work. Or you can go straight into equation 2. Right, so you're trying number 5 hard now. Sorry, number 5, sorry, 5 medium. I'll change this with this number, this thing, right? Number 5 medium, we do it. I just have it mixed up. But I can edit this. I'm just trying to get used to latex. Latex. Can I what type of this? Latex. It formatted nice. It was so cool.
Just
When I put all together. And anybody figure out 5s? Yeah. I know. I do it here. I'll do them, that's fine. I am waiting on Shazana. Shazana, wait, not Shazana. I said right? Edinburgh, right? Shazana. What I mean. Okay, Peter, Straight up by which? Huh? 5.5? You finish all. They finished number 1 already. Hold up. These two is there. Right? There were like 2 questions I pulled from paper, but I just removed it with no diagram. Because I can't draw that. Why a couple of questions I gave you this already? Why you went out into the back? That's not wrong. We didn't do that. Alright, number 5, medium. A ball is thrown downwards. So a ball is thrown downwards, right, with an initial velocity of 5 meters per second from a height of 40 meters. Right? How long will it take to reach ground? Right? So the displacement is 40. The initial, we know acceleration is 9.8, 9.81. 9.8. 9.8. So they want the time taken to hit the ground. So which equation is that? BSANT equation 3. Right? So we're going to use S is equal to UT plus a half AT squared. Right? S is what? S is 40. So this is the one you need some project So we have 40 here. The initial velocity is 5. The time is t plus a half acceleration going down. So it's positive 9.8 t squared. Right? So I have a little quadratic here. What's half of 9.8 again? 4.9, right? 4.9 t squared plus 5t minus 40 is 0. That's a quadratic. Right? So you have to go in a calculator and solve it. Okay, so you got a little quadratic. I get oh, that's what you get? Fail get that, so we had to go. 2.39 so 2.39 seconds, the minus 2 count, right? If it happens the other way. Trouble? You got up? Yes. Any questions? All right, so all I did is I just substitute, use the right equation and work it out. Yes, you would get quadratic something. You would get quadratic something. Try number 1 now. Number 1 hard. Yeah. Right, so you're looking how to use the equations of motion. Right. Let's try number 1 hard. I'm mainly interested in number 1 hard. Number 1 hard. Yeah. He was impressed. He was impressed when he did it. So he impressed there. So what he used to do. It's so what he do? He created his own what? He just uses what he had right. And model and then this trade. Let's trade the find of And how we deploy it, how we want that. It's to make them look, yeah, how you get the subscription. And about it, but today you can just use, I feel that we get to do it, and then stick up with something, they get through that. Maybe the market wants to, I don't know how much. Why don't we? See? See. Set up, I'm glad. It's good that I do the two, right? I don't do it in Taiwan. I thought that was. So what I use is the gas is not treated, yes, the same. My problem is, I don't know how to flow. So like, when I share my psychology. I know how to no, the same way for using the example of my account. So I don't know how to do that. You figure out so talk about so self radio. But I can do it with blood. It was a crash on the night. I gave us a crash on the night. Yeah, because I'm because no, you just be oh, so it is crap on the yes, losing money. So easy. I don't know. Really, I think it's easy. Also have something similar. You're done? All right, you'll get through that one? No, time up. Yeah, I'll go on right now. Well, go into a ring.
So
Yeah. That's not something you can read it first.
yeah, negative dimensions.
So all of probably means that you choose the wrong direction somewhere, right? So you bullet is fired horizontally from a height. So we have a height. So I'll go and draw a diagram. This is number 1 in hard, right? You have a diagram. You shoot a bullet horizontally. Horizontal. This is very important. Directions are important, right? So you shoot a bullet horizontally. 50 meters per second. Online, you're with me, right? So I'm trying to re-explain number 1 here. from a height 80 meters with an initial velocity. So the height here is 80 meters. Okay, how long will it take to hit the ground? Right, so most likely it will hit the ground somewhere around here, right? So it will go like this and hit the ground. That's okay? Because when you shoot the bullet, because of gravity, it will follow a path, something like that, right? I saw a building up to. I saw a building up to show you later, but I want to show you something that you don't need to know all that to solve it. Right? So it will hit the ground somewhere here, right? So they want the time to reach here and how far will it travel horizontally before hitting the ground. So how far will it travel here? Let's call that R. That's okay? So we had to use all the information given to find those two things. And remember, gravity acting downwards, gravity is 9.81. Well, okay with that? So let's see if we could find the time taken to reach here, right? What do we have? So I'm taking a look at what we have, right? I'm going to check out horizontally what we have. Horizontally, we have the initial velocity, which is 50. And horizontally, we could find the displacement, which is R, horizontally. That's okay? That's all we have, right? Vertically, we have acceleration, which is 9.81. Positive because it's going down, and we have S, which is 80 meters, right? And so we had to see which one we could use different time, right? You okay with that? Right. So I just want to ask something, right? If something moving horizontally, 50 meters per second, right? Remember we learned about components. So if I have a force acting horizontally, right? What is the component vertically? So I have a force acting on this, and the force pushing this horizontally. What is the vertical component? What is the vertical component? Nothing, right? Because the horizontal force causing it to move horizontally. No vertical motion. So it means it has no component, right? Okay with that? So if I have a bullet now moving horizontally, is there any vertical component? Initially? Initially. None. So what will be the initial velocity vertically? 0. You okay with that? You sure? So because it's moving horizontally, it has initially horizontally, but remember, it was started to that, right? But horizontally, initially has a velocity of 50, so it has no component vertical initially. Elijah, you okay with this here? Why the vertical velocity is 0? Yeah? You okay with that? So we have U, we have A, we have S. Here we only have U. So I can't find R, right? We have U, we have A, we have S. Can we find T? Can we find T? What's the equation we could use? Well, ignore this, right? What we have U, we don't have V, so I can't use that. We have U, we have S, and we have E, and I can solve for T. You're seeing that? And then when I find T, it will be the same T here, and see if that can help you find out. Right. So try and find T here, and then see if you can find out. Huh? Yeah. All right. Yeah, so what we got? Oh, you're working it out, sir? Right, so one thing I want to point out here is that what you're all doing, you're all technically using these equations without knowledge of projectile motion equations. So what you all just did was a projectile question by just looking at the equations of motion. Do you realize that? Right, so we're using S is equal to UT plus a half AT squared. S is 80, U is 0 by a half by 9.8 by T squared. Substitute, work it out, and you'll get T is the square root of 160 over 9.8, which is how much? 4.04 seconds. And now that I know the time taken to reach here, right? So now that I know the time taken is 4.04. I know the time, I know the velocity, so I can find the range. Right? Everything I have here horizontal, right? So now I can come and use any equation with US and T, so I can use this last one here. S is equal to V by T. The velocity is 50, and the time is 4.04. Okay. We have any other options, Ollie? I don't really have the final velocity, so I can't use this, right? I don't have acceleration horizontally, so I can't use none of these, so I have to use this here. How much is this? 202. Ready?
I think that's the idea.
Okay or not? Online, you're okay with that? Let me check out the messages here. Good job, Katrina. Online, you're okay with what happened there? So what this question does, it kind of gives us the foundation now to go into projectile movement, right? But not this week, next week, right? Have 9 now? Oh, Elisha, come. Dylan, you okay? Darian. All right. Let's see if we can squeeze in the next one now. We might be able to squeeze in all the rest. Not so bad.
Pretty sure that Sweden.
Yeah, no time. We really have a lot of time. Let's do number 2. 2 and 3 easy. 2 and 3 easy. 2 and 3 really easy. And basic stuff. Craft number 3. Craft number 3. Let's do number 2 and then we go to number 6. Number 6, just reading it alone is strong enough. Try number 2 and then do number 6. Try number 2, then we can look at number 6. Based on 0.15, based on they give the juries a lot for like that's I mean I feel like they're not sure they don't think that because needs out this law basic program no no assuming I have to program yeah. This is what it feels like. It makes no sense. Yeah, definitely. Get this point. Fine. Okay. Now we take example. No, this not good. That was a true one. It's still, huh? It's still in my, yeah, what, but you just, if you're, you know, This one up.
Really?
Oh, which another one? Six. Six is just plenty words. That's why I like this. All right, let's check it out. Let's start.
That's one. Yes, you one, right? Number
What three, right?
6.
And do number two. That's number one then. Right, so I want you to remember this for next week, right? I'm gonna send you a little note on projectile. I want you to read it through. Right? It's in the notes too, but I'll send the next one. I like the this one don't have much mistakes like that. Oh wait, I think I got to read it. Online, feel free to send your answers, right? You check it out and see what you got. Where is it? Right, equation, hardest number two. Hardest number two. A car accelerates from, so they give you the initial velocity, 20 meters per second. The final velocity, 50 meters per second. Over distance of 300 meters. Find the acceleration. Really easy, basic stuff. Right, so we could use b squared is equal to u squared plus 2as. Everybody in the same direction. Yeah. So we'll get a is equal to b squared minus u squared all over 2s. So that's 50 squared minus 20 squared over 2 by 300, which is, what was this one? That's number two. 3.5. 3.5 meters per second. Yeah, Tama. Yeah. You put it two at the bottom. Yeah. Two. Right? So put this and make sure you have a two. Right? All right, let me see. We can't finish number 6. We can start it. Anybody have answers for number 6? Huh? Please, Pressure. Pressure with number 6. So a rocket moves upwards. A rocket moves upwards with a constant acceleration of 30 meters per second squared for 20 seconds. Right? After which it runs out of fuel. Right? After which it runs out of fuel. Now, they didn't say anything yet, now, right? It might still be accelerated. Maybe slower.
So what you have to do,
I said something, but let's gather read that, right? right? So a rocket moves, it moves upward with a constant acceleration of 30 for 20 seconds, right? So it starts from here and it reach here in about 20 seconds. So we call it S1,
S2.
right? And then it continues to rise freely under the influence of gravity,
Decelerated, right?
right? Calculate the maximum height. So we had to find a way to use the information that we have to find S1, right? And then after we find S1, remember, it will stop. It will, when it reaches here, it's still moving. So if you could find the final velocity here, okay, sorry, I will tell you everything. What do you do?
So I use B is equal to S over T, right? Define S1, right? Because we have B and we have T.
No, that E.
That's B. I'll switch up one line. That's B. Switch up one line. It's called
The same constant
constant
acceleration.
acceleration. Because that's B.
No, that's E.
So then what
Alright, but tell me why it is, tell me why it is, because you have the right idea.
then I really for that go for S, right, which is 50 by 20, which is 500, right?
So you found for S.
So yeah,
Right.
S1 will be 5. If it's correct, S1 will be 500, right? But then it will still go up.
Right.
So then I use, so then I said the final the initial velocity will be the final acceleration, whatever, which is 30 meters per second, right?
You have the right idea, but everything is, you're mixing up two little things. You're almost perfect on what you're supposed to do. So you're supposed to find S1. This is the acceleration at the time. What's the initial velocity of this? 0. Right? So if you have the initial velocity and time and acceleration, then you can find it. You can find S1. And then if you find the final velocity for this ship, if you find the final velocity, put it here, and that will be the initial velocity going up there. Yeah. And then if you know the initial velocity here, when will it stop? It will stop when what?
Then gravity.
Well, it will stop when V is 0. Right? And then use the tell you what acceleration is. And then you find for the next. So I'll show you which equation. So I want you to sketch this diagram. See if this is helpful. Right? And I want you to find S1 and then attempt to find S2. Okay? So you're finding S1 using the right equation, then you're finding S2 using this information here. The final velocity that this rocket reaches here with is the initial velocity into the new phase. So it's moving, and when it's, the fuel done, it's still moving, but with that velocity. Okay? Until it reaches maximum height. Alright, stop here now, and what you will do is you'll finish up the homework. And then for homework, you can try the others after number 6. Okay, and I'll give you some solutions and we'll work it out. So for homework, finish 7, 8, 9, 10. And then 3 lessons today?
Yeah.
Okay. Go ahead now and come back and leave any notes. Go fast.
Yes.
Alright,